Okay, I'm back, and so now we want to talk about a different kind of metamorphism. So the first kind, regional metamorphism, was you were applying both heat and pressure to something. So now we want to talk about what would happen if you just apply heat to it. So a typical example of this might be where you have a existing rock. So let's say that it's some limestone, and then for some reason a magma body comes up, and so you have this magma down here that is in contact with the limestone. What's going to happen? So it's not being subjected to pressure, but the limestone is being subjected to heat. And so what will happen is the calcite in the limestone, it will reorient itself and will recrystallize as the metamorphic rock marble. So marble is still made of calcite. So what do you think would happen if you put some acid on marble? It would fizz because it's still made of the mineral calcite. It's just that it's more compact. Okay, then what about sandstone? So sandstone is going to be made of quartz, and then if you subject, so let's say instead of limestone up here, let's say that this was some sandstone and it was right next to a magma chamber, so it got heated up to the point at which those quartz grains reorient themselves and grow, then you end up with quartzite. Now the difference between these two is if you take a geological hammer and you hit limestone, you can break it apart, and you can break sandstone apart too. But if you take your geological hammer and you hit marble with it, it's much harder. And the same thing for quartzite. So quartzite is still made of quartz. So we did not change the identity of the minerals. Okay, then another kind of contact metamorphic rock is going to be called a hornfels. And so you notice that you can basically start with any kind of rock and then subject it to heat, and it can be transformed into a hornfels. And a hornfels, it's not very spectacular. So it's just this kind of a blocky, greenish, blackish rock that is the product of basically any kind of rock when you subject it to contact metamorphism. So let's look at another kind of metamorphism. So this is going to be hydrothermal. So you're going to need some kind of a fluid. Most generally it's going to be water. And you need thermal, so it has to be hot water. So where could you have this? Like at a mid-ocean ridge, where you can have ocean water that is circulating through the rocks and then gets heated up. And so as it goes through other rocks, it can metamorphosize them. You could also have a geyser, would be another example, hot springs, where this could happen. And so one example of hydrothermal metamorphism would be if you take the original rock, so this is the igneous rock periodotite, and you're going to subject it to hot water, and it turns into the metamorphic rock serpentinite. So serpentinite has in it the mineral serpentine. Okay, then you could also have rocks that are just buried. So an example of this would be coal. So we said that you start off with a swamp, and then as the trees fall into the swamp, more trees fall on top of them, and eventually all of that organic material gets buried before oxygen can get to it and decompose it. So you've got all of this carbon that is being squished together due to the weight of the material that's on top of it. And we said that the first material that would form was called peat. So if you take peat and you continue to heat it up and you continue to bury it, at first it's going to turn into lignite coal, and then the lignite coal, if you continue to bury it and heat it, will turn into bituminous coal. And then, now all of that was sedimentary rocks. So if you continue to heat the bituminous coal, it will metamorphosize into anthracite coal. And you'll notice that one of the distinguishing characteristics of anthracite coal is it's much harder than the bituminous or the lignite coal. And you'll also notice it's kind of shiny. So those are some ways of telling if you've got anthracite coal on your hands. Okay, then you could also have rocks that get caught in a fault. So where the rocks are moving past each other, the rocks that are in between where the two rocks are at can be pulverized. So if you start with any kind of a rock, so it could be an igneous rock, a sedimentary rock, or even a metamorphic rock, and you subject it to these stresses where these plates are moving past each other, you can shatter the rock, and then it can be welded back together as fault breccia. Now, if you also apply heat to it, in addition to the forces in between the two plates, you can smear out those pebbles and crystals, and you can end up with what's referred to as a myelinite. Okay, and then our last category of metamorphic rocks is going to be caused by an impact. So this is when a meteorite or a comet strikes the Earth, and it's going to have a lot of pressure because it's going to push into the ground with a lot of force, and it's going to be very hot, so it's going to have lots of heat associated with it. So if you take any kind of rock and you subject it to this impact, those rocks can be altered, and as they are ejected from the impact site, they form these little molten pieces of stuff called a tektite. All right, let's take a break and let's talk about what a migmatite is.